Lecture 1, Basic of Probabilities. So before starting the course, you have to know the basic concept of the probability. So what is in probability theory? Human life isn't full of uncertainty. In the probability theory, the degree of certainty and uncertainty of the such event is measured in the term of number lying between 0 and 1. So first you have to know what is an experiment. So an operation which result in some well-defined outcome is called an experiment, while an experiment whose outcome cannot be predicted with certainty is called a random experiment. So in the probability theory we are using the random experiment. Sample space. So the set of all possible outcome in the random experiment is called sample space for that experiment. Means those outcome which come from the random experiment, that is called the sample space. For example, when a dice is thrown, a sample space is what? 1, 2, 3, 4, 5, 6. These are the outcome when we throw a dice. Now, what is an event? A subset of a sample space S is called event. Suppose we take A is equal to 1, 2, 3. So here A is an event occurring of an odd number when we throw a dice. So you see there that A is a subset of this S. So the event is what? Is an always subset of a sample space. Sometimes we say equal likely events. So what is an equal likely events? Event, or we can say the outcome, are said to be equal likely when we have no reason to believe that one is more likely to occur than other. Or we can say when unbiased dice is thrown, all the six faces 1, 2, 3, 4, 5, 6 are equal likely to come up. The next term, that is mutually exclusive or disjoint events. So if we say we have more than one event, that is two or more than two events are said to be mutually exclusive if no two of them can occur together. Suppose we have an A1, A2, A3 are n mutually exclusive events, then we can say any two AI, AJ is phi, means intersection of these two, any two event is what? Phi. So such type of event we can say so mutually exclusive or disjoint event. Suppose we take A is an event when we throw a dice is 1, 2, 1, 3, 5, the odd number, and we take another event B is an event occur on even number, we can say 2, 4, 6. So A and B both are what? Because the intersection of AB is phi, so we can say A and B events are mutually exclusive or disjoint events. Probability of an occurrence of an event. So first we take the definition. Mathematical or a classical definition of probability says, let's say S be a sample space, then the probability of an occurrence of an event is denoted by P E and is defined as the number of element in the event divided by the number of element in the sample space. So that is number of cases favorable to the event E and total divided by total number of cases. That is the probability of an such event E. For example, suppose we are taking a 21 ticket numbers and numbered are 1 to 21 on each ticket, and one ticket is drawn at random. Find the probability that the ticket drawn has number divisible by 3. So here the sample space is what? We have 21 number ticket. So as be a sample space and we suppose T be the event occur of the ticket having the number divisible by 3. So you know the event, the number of events is what? 3, 6, the multiple of 3, 9, 12, 15, 18 and 21. And S is what? Is a total complete sample space, that is 1 to 21 number ticket. So here the number of element in S, that is sample space, we having 21, and the number of element in the event is what? Is 7. 1, 2, 3, 4, 5, 6, 7. So here the probability of getting the ticket drawn as a number divisible by 3 is what? 7 by 21, that is 1 by 3. So it's very simple. One more example, two dices are thrown simultaneously. What is the probability of obtaining the total score 7? So as you know, when you throw the two dices, what's the sample space? So here we suppose we have throw the two dices, so the sample space is says S, and we take a E be the event obtaining total of the score 7. So the sample space is what? Two dices, 1 2 3 4 5 6 into 1 2 3 4 5 6. So we obtain the order pairs here 1 1 1 2 and so on. Similarly 1 to 6, similarly 2 1 in first dice, 2 in second dice we say 2 and so on, 2 6, and similarly 6 1 and up to 6 6. So this is the sample space, the element to the sample space. So total we have how many sample points are there? Total 36 sample points in the sample space. Now the event, we have to find the probability obtaining the total score 7. So here 1 6 2 5 3 4 4 3 5 2 6 1. So the total we have 6 in the 6 element in the event. Therefore the probability of obtaining total score 7 is what? The total number of available cases we have 6, and the total number of cases is 36. So we say 6 by 36, we get 1 by 30, 1 by 6, that is the probability of getting total score 7. So in this way we can easily simplify, easily find out the probability. If 6 boys and 6 girls sit in their row randomly, find the probability that all the 6 girls sit together. So here the random experiment, 6 boys and 6 girls are sitting in the row. So sample space we are taking S, and the event, the probability we have to find all the 6 girls sit in together. So the event we consider all the 6 girls sit together. So here the total number of way to sitting a 6 boys and 6 girls is what? Is factorial 12 ways. So in factorial 12 ways we can set it 6 boys and 6 girls, means we have total 12 peoples. So here all the 6 girls are, if we consider all the 6 girls as a one person, so we have how many? Only 7% is there. 6 are boys, plus if we consider all 6 girls as a one person, so total we have 7%. So 7% can be seated in the row how many ways? Total 7 factorial 7 ways, but 6 girls can arrange among themselves. Therefore the 6 girls are factorial 6 ways to seated in the in a row. So the total number of way to 6 boys and 6 girls in a row, so we can say the all 6 girls sit together factorial 7 into factorial 6 ways. So this is our the total factorial number of cases, and total number of cases we have factorial 12. So after simplify, after finding the probability, we get factorial 7, factorial 6 and factorial 12. On simplify this, we get 1 by 32. So the probability of getting all the 6 girls seated together when we have 6 boys and 6 girls is 1 by 32. Now one more concept we have to understand: independent and mutually independent events. So if we say two or more events are said to be independent if occurrence or non-occurrence of any one of them does not affect the probability of occurrence or non-occurrence of other. In other words, we can say the two or more events are said to be independent if occurrence or non-occurrence of any one of them does not influence the occurrence of non-occurrence of the other. For example, if we toss a coin, suppose we toss a coin, 2 coins or 3 coins, then the event occurring of a head in a first throw and the event occurring head in the second throw are independent events. And when we say in the case of 52 playing cards, if we're taking the 52 playing card with replacement, if we are taking with replacement, then when we draw the first card is put back in the pack, and then the second card is drawn. In that case, the events of the occurring, suppose we take a king in the first row and the event occurring the king in the second row are independent, because the probability of drawing king in the second row is also 4 by 52, whether the king is drawn in the first row or not. But if we take the two cards are drawn without replacement, then the events are not independent. In that case, the event are dependent, because in first, if we draw a king in the first draw, the second draw the probability is what, 3 by 52. There are some important points you have to note it. If suppose we have two event A and B are two events, then A intersection B, or we can say sometime we write A into B, denoted the event simultaneously occur both the event A and B, or A intersection B occur if and only if A and B both are occur. So, and if we write A union B, or sometime we write A plus B, is denote the event of occurrence of at least one of the event A and B, or we can say A or B. A union B occur if at least one of A or B occur. Now if we write A minus B, it denotes the occurrence of event A but not B. So remember, A minus B means implies A occur, B does not occur. Sometime you have to, we can write also A minus B is A intersection B complement, or B minus A we write B intersection A complement. And if A and B are mutually exclusive events, if and only if A intersection B is phi. So in that case, the probability of A union B, we write probability of A plus probability of B. But if A and B are not mutually exclusive, so in general we write A union B, probability of A union B, we write probability of A plus probability of B minus probability of A intersection B. And similarly, if we have three events and they are not mutually exclusive, so we write the probability of A union B is what? A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So these are some points you have to remember. Now we see the one example. Suppose we have an urn contain 10 white, 15 red and 25 black marbles. So we have to determine the drawing of either a white or a red marble, and second either a white or a red or a black marble. So here you see, if we say the probability of getting white marble is what, we have 10 white marble and total we have 50 marbles. So the probability of getting white marble is 10 by 50, that is 1 by 5. Similarly, probability of getting red marble is 15 by 50, that is 3 by 10. And probability of getting the black marble is what, 25 by 50, that is 1 by 2. Now in the first case we have to find the probability either a white or a red marble. So when we use the case or, so we use union. So the required probability of getting white or red marble, so right probability of white or red marble, that is W union R. So probability of W plus probability of R, we get 1 by 2. Here we are not using the probability W intersection R because these two events are the getting a white marble or getting a red marble are mutually exclusive events. And the second case, as you know, the white, red and black marble, drawing of the white, red or black marble are mutually exclusive. So the probability of getting W union R union B is what? Probability of W, that is white, probability of red marble plus probability of black marble. So we get 1. So this example is depend on the not mutually exclusive events. Two dice are thrown once. What's the probability of getting an even number on the first? Or a sum is 8. So here the sample space is what we have to draw. We have to throw on a two dices. So S is a sample space, and you know the total number of element in the sample space is what, 36. So here we take a let us consider an event, says A be the event, sum of the number on a dice is 8, and take another event B, the event that number of number on the first die is even. So the A event is what? The sum is 8. So we have 2 6 possibilities are 2 6 4 4 6 2 3 5 or 5 3. So total we have 1 2 3 4 5. So we can say the element in the event when the sum of the number on the dice is 8 is 5. And the second event B means when the event that the number on the first dice is even, so it's possible 2 2 1 2 2 2 3 2 5 2 4 2 6, and similarly 4 1 4 2 4 3 4 4 4 5 4 6, and similar for the 6 1 6 2 6 3 6 4 6 5 and 6 6. So total we have 18 element in that event. Therefore the probability of A is what? 5 by 36, and the probability of B is what? 18 by 36, that is 1 by 2. Here you see A and B. Here we have two events, A and B event. These two events are not mutually exclusive, because when we take the A intersection B, so there are some elements are common, that is 2 6 4 4 and 6 2, that is 6 2 6 2. So these three elements are common. So we can say A and B are not mutually exclusive, or sometimes we say they are not disjoint. Hence we can say the A intersection B, we have three elements. Now the probability of A intersection B is what? 3 by total number of sample space is 36, so we get 3 by 36, that is 1 by 12. Hence the required probability is what? Probability A union B, because we have to find the probability of getting an even number A intersection union, the sum is 8, that is A and that is B event. So the probability of A plus probability of B minus probability of A intersection B, and on simplify we get 5 by 9. So in that way we can find the required probability. You have to remember here, if A and B are not mutually exclusive, so we use that formula. Thank you. Continue the next lecture.